Stop coding, start orchestrating. 95% of programmers are being replaced by execution AI, and the chat window is officially dead.
Let's get started with the details.
"95% of programmers are already being replaced by this AI. I know that sounds crazy, but we are standing right at the precipice of a massive structural shift in software development. For the last couple of years, the whole industry has been completely captivated by what artificial intelligence can say. But right now, the entire developer ecosystem has aggressively pivoted toward what AI can actually do. We have definitively moved beyond chat, guys. We are operating in the era of action. And the data and real-world benchmarks we're dissecting in today's explainer prove that this isn't some distant sci-fi future. It is actively rewriting code bases and replacing legacy workflows right this very second.
Take a look at this. GitHub's Gwen Davis just issued a stark warning that pretty much serves as the blueprint for this new reality. She said, "The era of AI as text is over. Execution is the new interface." I mean, that perfectly captures the absolute urgency of this moment, right? The fundamental interaction model between us and our computers has irreversibly changed. We're no longer just asking a model a question, waiting for a response, and then manually copy-pasting a text snippet back into an editor. That chat window? It's dead. The interface is execution. The AI is now an active, autonomous participant that writes code, runs tests, debugs errors, and pushes commits, all without you holding its hand.
Section 1. Era of AI text ends. Snowflake recently made a massive strategic pivot, basically betting their entire future on the reality that AI is no longer just for analyzing data, it's for acting on it. And this starkly contrasts the kind of obsolete world of chatbots with the dominant new reality of autonomous agents. Think about it. A chatbot is passive. It tells you how you might fix a database error. But an autonomous agent, driven by breakout tools like Devon AI or those incredibly advanced agentic features inside Cursor, actually gets the work done. Devon doesn't just suggest code. No, it literally spins up a secure container, opens a terminal, reads the API documentation, writes the migration script, tests the new schema, and deploys the whole thing. It's the profound difference between having a really smart search engine and unleashing an incredibly capable, relentless digital engineer directly into your environment.
Section 2. The scale of the shift.
60 million. That is the staggering number of Copilot code reviews that have already been executed. Let that sink in. Human teams simply cannot keep up with AI code generation speeds anymore. In fact, recent independent studies benchmarking autonomous AI against human engineers reveal a genuinely startling reality. These AI workflows are now resolving live GitHub issues with higher structural quality and at drastically faster execution speeds than their human counterparts. The algorithms are pushing updates so rapidly that we're completely bottlenecked. We're literally forced to rely on AI to review the very code that AI is writing, simply because our human capacity to review pull requests manually has been thoroughly overwhelmed.
And the financial capital accelerating this execution-based reality is absolutely massive. DeepMind's David Silver just raised $1.1 billion to build an AI that learns without human data. Over $1 billion. This investment is aimed squarely at severing the AI's reliance on human input altogether. So instead of just mimicking our past, flawed code, these models are using reinforcement learning to discover optimal software architectures that humans haven't even conceived of yet. When autonomous agents begin learning and executing entirely outside the boundaries of human training data, the timeline for legacy developer obsolescence accelerates exponentially. It's wild.
Section 3. Running multi-agent workflows. So, to survive this shift, we need to clearly define the exact technology driving it, agentic workflows. As GitHub's lead engineers point out, this represents the ultimate leap to programmable execution. It's no longer just one monolithic AI trying to juggle every single aspect of software creation. Nope. It is the sophisticated orchestration of multiple, highly specialized collaborative agents operating natively right within a single repository. Imagine having one agent entirely dedicated to writing back-end logic, which then smoothly and automatically hands off context to a secondary agent specialized in optimizing database queries, while the third focuses strictly on front-end integration.
Tools like the GitHub Copilot CLI bring this exact orchestration directly to your fingertips with commands like /fleet. Let's look at a practical scenario here. Say you invoke a single /fleet command to build a web application. Instantly, the system dispatches multiple agents in parallel. A back-end agent provisions your database schema, while a front-end agent is simultaneously wiring up the React interface. To orchestrate this, your role has to completely change. You have to engineer initial prompts that expertly split the work across files, rigidly declare all your dependencies up front, and map out the architecture to avoid those complex merge conflicts. You aren't typing syntax anymore. You are managing a synchronized fleet of autonomous digital workers.
Section 4. Securing agentic AI systems. Now, multi-agent workflows often fail. So how do we build ones that don't? Gwen Davis offers a brilliant insight on this critical vulnerability. She highlights that when a multi-agent workflow collapses, it almost never comes down to the underlying AI model lacking intelligence or capability. They actually fail due to missing structure. Think about it. When an autonomous agent goes rogue, wipes a directory, or gets trapped in some crazy infinite execution loop, it is fundamentally an engineering failure in how the agent's environment was designed and bounded. It is not a failure of the AI itself.
Because of this, GitHub developed a rigid security architecture to run these agents safely at an enterprise scale, and it rests entirely on 3 non-negotiable pillars. First up, strict isolation. Agents absolutely must be heavily containerized so an experimental front-end script doesn't accidentally have the permissions to alter a production database. Second, constrained outputs. You have to enforce strict data schemas, ensuring the agent delivers exactly the expected format and literally nothing else. This prevents runaway code generation. And third, comprehensive logging. Look, when an agent is capable of writing and executing thousands of lines of code in seconds, having a perfect, unalterable audit trail of every single decision it made is your only defense when something breaks.
Section 5. AI reshapes developer choice.
This specific finding from the October's 2025 data really demands our attention. It states, AI compatibility is becoming the new standard for technology choice. The data definitively proves that AI is aggressively rewiring developer preferences through convenience loops. Basically, if a framework, a library, or an open-source platform is not natively compatible with agentic execution, meaning if tools like Cursor or Devin struggle to parse the documentation and execute tasks within it, developers are just ruthlessly abandoning it. They are migrating exclusively to tools where the AI works flawlessly. AI capability is no longer just some added feature. It is the ultimate, uncompromising filter for technology adoption.
Section 6. Adapt, execute, and survive. So, to stay relevant in an industry moving at this insane velocity, adaptation is literally mandatory. First, you have to master execution-first tools. Whether you're using Copilot CLI, migrating your workflow to Cursor, or leveraging Devin, you must stop copying and pasting code, period. Move directly from intent to orchestrating pull requests generated by the system. Second, integrate continuous AI-powered issue triage to instantly resolve backlog vulnerabilities without human intervention. And third, actively build your agentic security skills. Right now, thousands of engineers are already using GitHub's open-source secure code game to hunt down and exploit real-world agentic AI vulnerabilities. You absolutely must know how to hack an autonomous agent if you want to properly secure it. The shift from text to execution is already here, completely rewriting the rules of the repository and the very definition of software engineering. So I'll leave you with this. If agents are autonomously writing, reviewing, and deploying code at a scale and quality that surpasses human benchmarks, will your current coding skills even be recognizable a year from now? Thank you for joining this explainer. Subscribe to stay ahead.